This meeting is being recorded. Thank you, Zoom.
Hey,
Cool.
everyone.
Oh, nope, go ahead.
Okay, thanks for joining us for our skill session on Intro to Unity. I will share my screen real quick, just to get us started. All right, everyone see the screen all right?
Okay.
All right, as always, if you guys have any questions about future past skill sessions, email te@nd. Afterwards, we're hoping to post this video up on YouTube, so in case you ever want to revisit it, be sure to check it out. And like I said earlier, this session will be on Intro to Unity, taught by Garrett and Kain. So Garrett is a 5th year at Cal Poly San Luis, and Kain is a 4th year at San Diego State University. So I will go ahead and pass it off to them.
Cool, awesome. All right, let's get the screen share up and going. Hi, everyone. Hope you all are having a good week. Let's see, how do I, uh-oh, PowerPoint is covering Zoom. It says you've disabled screen sharing. Could you enable that? Cool, awesome. All right. Hi, everyone. Welcome to Intro to Unity. Like Caitlin said, my name is Garrett. I'm a 5th year at Cal Poly San Luis Obispo. My sort of specialty is game design with a focus on how it relates to themed entertainment, interactive design. Kain, do you want to, give a brief introduction about yourself?
Yeah. So most of my game development experience, I would say, is from being president of SDSU's game development club called Aztec Game Lab and our VR club. I also just really like working in game engines on my own, working on personal projects.
Cool, cool. All right. Well, so this is going to be a very introductory sort of, workshop of, showing what Unity is, and sort of potential uses, so on and so forth. So we'll start with what is Unity. So Unity is a game engine. In a game engine, it's the most widely used game engine in the world, along with Unreal Engine. Here we have a couple of pictures of what it looks like. So you might ask, what is a game engine? So a game engine, unlike something like Blender or Maya, which is mainly used for 3D modeling, a game engine goes a little bit beyond that. So a game engine is a set of tools for essentially real-time simulation. And this includes many different moving parts that work together. So that includes a real-time rendering pipeline, which allows a computer to render materials and models in real time. A real-time scripting engine, which is basically what allows these models to interact with each other. Basically code that's constantly being run in your background that controls how your simulation works. And then you have all sorts of other things such as input, sound, animation, networking. The list goes on and on. We won't get too in-depth into all that different stuff today, but yeah. So Unity is primarily used for games, or I guess game engines in general are primarily used for games. But recently, they've also been starting to be adopted by other industries, which includes like architecture, building information modeling, so on and so forth. And we'll talk about some of those other uses later on in this presentation. So here are a lot of different examples of some of the game engines that exist out there. Of course, we have Unity and Unreal, which are the two most used. And then you have stuff like Monogame and libGDX and GameMaker Studio. There are hundreds of them out there. So, and they all have their different pros and cons. And, as you start to work with a lot of them, you start to learn, which ones work for the best or for which use cases. So for those of you gamers, here are some examples of some games that are made or that have been made using Unity. Cuphead, Hearthstone, Ori and the Blind Forest, Monument Valley. But that's not all game engines can be used for. So they can also be used for anything from interactive installations like kiosks. Like as you can see, this is a ordering ordering coffee, I think. Yeah, for a Starbucks or a Burger King or something like that. It's also used in film, and we'll touch on a good example for that a bit later. Architecture modeling, it allows you, to simulate and sort of walk around your model for a certain building or something in real time rendered in VR, which is very cool. And also simulations. So let's sort of get started. So Kain and I are going to sort of walk you all through like sort of the beginning process of creating a very simple game in Unity. If you do have Unity downloaded, you can follow along with us. If not, of course, you can always come back and watch this video. At the end of the presentation, we'll also be giving some resources if you want to, go a little bit more in depth and learn more. So, Kain, do you want to get us started?
Let me share my screen. All right. Do you see my screen? Okay, cool. So
someone's looking at cat pictures.
My desktop's a mess, so. Okay, so if you have Unity open, this is called Unity Hub. It lets you have a bunch of different versions of Unity installed, so you could work on different projects without having to mess with the different versions on each project. And to create a new project, we could click New right here, or click this drop down that lets you select from different versions. I'm going to work with 2020 1.4. And this will bring up a little tab that shows 2D or 3D and a couple other things. So yeah, Unity can be used for 2D games and 3D games. For this example, we're going to go with 3D. And for here, I will type TAA. Okay, and hit create. This will take some loading time. If is anybody following along? I want to make sure I don't leave anyone behind. Okay, so this may take a few minutes. I didn't think of what I should talk about during this time. Do you have VR in the slides later?
I don't have VR in the slides. Okay. I could talk a little bit about VR later on, assuming I can get this working. I actually have an example of a really good example of sort of a themed entertainment use case of Unity.
Oh yeah, asking questions would have been a good thing to do. Justin asks, is there a difference with what's the difference with 2020 and 2019? There's not too big of a difference. They're more advanced features. Don't remember.
Yeah, that's actually a great question. Unity is a very well supported engine. So there are a lot of very incremental updates that happen very frequently. They're constantly adding new features. So, if you work with Unity a lot, it's very common to have many different versions of Unity installed because, usually you'll stick with one version for a certain project, or you'll use another version for a project based on, the features that you need. Generally, if you're, just starting out, it's best to use the latest version or the latest stable version, which is what we're using right now, 2020.1.4 at the time of writing.
Yeah, it specifically says LTS, which means long-term support, which means that, it's going to be the least buggy version. So a lot of actual game studios and companies that use game engines won't use the newest version because it's not necessarily the most stable.
Yes, and yeah, a lot of companies will also, yeah, like Kain said, stick with older versions because one, they're more stable, and two, whenever you update a project, there's always a risk of incompatibility. Danielle asks, are there compatibility issues between various software versions, like if you try to open a 2020 file in 19? So generally, downgrading in Unity is not officially supported. Upgrading is technically, but I mean, technically,
yeah.
like, but there's always a risk of incompatibility.
So I got my Unity open, but if you're following along and it's not open yet, can you hit like no or something, or say something in the chat just so I don't like leave you
We'll
behind?
definitely. Yeah, we want to make sure everyone's on the same page.
Okay, I think we're good. Cool. So this is Unity. Welcome. There are a few windows. I think that's what I should talk about first. So this is the scene view, right? You see my mouse, by the way, right? Okay. This is the scene view. This is kind of like a God view where you could kind of take yourself, your camera, wherever you want to look around. This is the game view. So when you actually play the game, that's the scene that you'll be looking through.
Yeah, so the game view represents what the screen or the player sees.
While this scene view is kind of just, you could take it wherever you want to develop. This hierarchy is a list of all the objects in this scene.
So we'll explain objects in a little bit.
A console is a bit more like traditional coding, where if you want to print something out through code, it'll pop up right here. Also, if there's errors, it'll pop up here. This project window contains, it's kind of like the file explorer in Windows and Macs. You could import images and assets that you could use for this game. The inspector right here is, it changes based on what you have selected. So if I click on main camera in the scene, you'll see some information pop up.
Yeah, and we'll explain all that in a little bit.
Yeah.
So do you want to talk about scenes?
So scenes are just a file that contain different objects. You could imagine it kind of being like different levels to a game, maybe. So you might have like separate a game into different levels with different environments.
And sort of to parallel this to, some other forms of entertainment that you might be familiar with, a scene in Unity is much like a scene like that you would find in like a TV show or a film. It's really just it's a group of things or objects, which we will touch on.
So if we want to add something to the scene, we could click this plus button right here. It'll give us a little drop down. And since we're working in a 3D world, let's go to 3D objects and put down a cube. There we go.
I just have like a question.
Yeah, go ahead.
Do we have to click the plus button, or is there like a right click that we can just press on as well?
Yes.
Yeah, if you do right click, same thing. In Unity, there's a lot of ways to do the same thing, which is kind of cool.
It can be confusing, but we're trying to make this as easy as possible. So yeah, every scene is basically just a group of objects, and objects can be anything from like scenery to lighting to a character maybe, and they can be placed in the scene like Kain demonstrated. They can be moved around, they can be resized. So do you want to explain like sort of the toolbar next?
Yeah, so the toolbar up here, there's 3 buttons that we mainly use. This one, the move tool, the rotate tool, and the scale tool. If you used any 3D modeling programs or animation software, you'll be pretty familiar with that. You just click on an object, and if you're in the move tool, you could use these axes to move it. Rotate, rotates it. Scale, scales it, of course. One thing I want to mention is if you look to the right in the inspector, you'll actually see all of these things changing. So if you want to type in a specific number, you could do that too.
Yeah. So, coming back to the inspector is basically a window that gives you all of the information on whatever you have selected. So Kain right now has the cube selected, so he can see all of the information that's relevant to that cube.
I think we should talk about the camera, just how to like navigate the scene for a
Yeah,
second.
sure.
There's two main ways to navigate the scene. One is to hold Alt and left click to orbit around. So I'm holding Alt and dragging with left click to orbit around a thing, and hold Alt and hold right click and drag up and down to zoom, and hold Alt and hold middle click to pan. So this is like most 3D modeling programs. If you're familiar with like first person shooters, you could actually hold right click and look around as if you're kind of like a person looking around. And as you're holding right click, you could use WASD to move forwards, backwards, left, and right. You can move around whatever you're the most comfortable with. But if you're new to that, it's a bit hard to get used to. So yeah.
Oh, can we scroll in as well or no?
Oh yeah, scrolling works for Zoom too. Yeah, it's the same thing as holding Alt and right clicking, scrolling.
Cool. So do we
quick
want to
question about scenes again? You said that they were sort of like individual areas. So then what about more like expansive or like open world like maps, almost like like Breath of the Wild, for example, how it like loads only when you get there? Is that when you're like connecting scenes? Is there a way to do that, or do you have to create each instance of a scene separately?
So generally, that would all be one scene. So basically, like it would be one giant scene, and then the objects in that scene are loaded dynamically as you sort of move throughout that scene. So that's a little more complicated than we're going to get in this workshop. But yeah, generally for performance reasons, yeah, those are usually like a big scene, but very well optimized so that it's not your entire computer isn't loading everything at once.
Yeah, there's some videos on Reddit that like shows like the camera view looking around, and you can actually see everything in the scene disappearing and only showing where they're looking around. So that's kind of related to that.
Yeah, that is a technique called culling, which we will not get into. Anyway, do we want to move on to components?
Yeah, so
Cool.
you'll notice these three objects, camera, light, and cube, are like very different things, but they're all considered objects. And the reason they could do such different things is because they have different components. So this main camera has this camera component right here. It also has this audio listener component and this transform component. Components are basically scripts that give features to objects. They could also allow users to create their own scripts, and you could have like inputs and stuff to create like a player that moves based on your input.
Yeah, components basically define an object's behavior, and they can be attached and removed very easily. They're very modular. Like Kain said, you can also create your own components through writing scripts, which we'll be doing in a second. And components can do anything from taking player input. They could move an object. They can also interact with other components. And yeah, that's basically how you define the behavior of your scene. So.
Oh, I just have a specific question about the what's called the camera. What does the audio listener do? Like, what is that specifically for?
So the audio listener is tied to Unity's audio system. Basically, Unity has a 3D spatial audio system where if you have an audio source that's playing audio, basically it'll calculate the distance from anything that's listening to that audio, and it'll adjust the effects and volume accordingly. So by default, when you create a scene, every scene must have at least one audio listener, even if you're not playing any audio, and that's just for compatibility reasons.
So it doesn't like create any audio, it just sort of it just creates the distance between
No, it doesn't. Yeah, it doesn't the audio listener itself does not create any audio.
Yeah, let me show
That's
you
just
this.
that's
So-
just a representation of something that can hear audio.
Mhm. Yeah, so if we actually go to this box, you'll notice these things. These render the boxes, and this collider tells the physics how to collide with this box. But if you go to add component, you could search for an audio source, and you could actually add this audio source component and like give it audio clips, and that'll communicate with the camera's audio listener to calculate like the distance between them and create realistic audio.
Yeah.
But we don't need that right here, so I'm going to right click on it and remove component.
Cool. So yeah, so we are going to be creating a very simple game, which is just creating a character that walks and collects an object. So Kain, do you want to sort of walk us through that?
Yeah, so this cube I made, I'm first going to just take the position to 0, 0, 0, just to kind of clean it. And this is gonna be like the ground platform where the player is gonna walk on top of. And then we're gonna need a player. So we go to create. I'm gonna use this capsule to represent a player. And we can move it up and move it into a position that we like. So for this game, we're gonna have. Oh, hey, Michael. My audio just echoed through you, I think. So we're gonna make a script that takes the user's input, so when we press the D key, it's going to move the player across, and we're gonna add a little coin that it collects to. Is anybody stuck at getting kind of like to this scene, to getting a capsule?
Is everyone following along?
Yeah.
Who
Okay,
is
cool.
using the engine?
And then, so we want to give this capsule a component that takes player input and moves this position based on the input. So that's going to be a script. And you'll see at the bottom of add component, or if you scroll down, you'll see new script. And you can name the script to player and click create and add. It'll take a second to load. Okay, and then if you want to edit the script, you'll right click it and edit. This will open up an IDE. Dang it, what was it?
Integrated development environment.
Yes, thank you, Garrett.
Yes.
Which is basically a text editor, but with advanced features like debugging tools.
Very fancy text editor.
Mhm. So this is where we get a bit into coding or scripting.
Yeah. So, I mean, obviously, we're not going to teach you guys how to code. That's not the purpose of this, workshop. But, we'll show you, sort of just enough to get up and running.
Is anybody familiar with coding here, by the way? Anybody learned a bit of coding? Oh, cool. Okay. So Unity, by default, starts off with two functions. You could basically put lines of code in here, like print hello. Oh, my computer froze. Okay. And basically, all of the commands inside of start will run once when you hit play. Meanwhile, update is a bit different, where it runs commands inside of this line every frame. And how should I explain frames? Games typically run like 60 frames a second. So this specific area of code will be running 60 times every second.
Yeah.
And this is good for like capturing input, because you don't know when a player is going to push a button. So it needs to check every frame if the player is pressing the button. Speaking of if, so I'm going to type in if input dot get key. Oh no, my IntelliSense isn't working.
Yeah, it takes a little bit, at least I guess for your machine, because we had this issue yesterday.
I think that's right.
So what language is this? This is C#.
Oh yeah, I should have started with that.
Yeah, no worries.
C#. It's a lot like Java, if you're familiar with that. Um, yeah.
Yeah, C# is an object-oriented language which combines the best of Java and C++,
Mhm.
ideally.
So I wrote this little block of code. So this is an if statement that's checking if the key code D, which is just the D key, is being pressed.
I think the C in key code is capitalized.
Key code.
Sorry, you're gonna have to do this blind because your
Yeah.
DualSense isn't working.
So one of the cool things about IDEs, like this one's Visual Studio Code, by the way, is that it has like really smart autofill that lets you code really quickly. For some reason, mine's not on right now.
Yeah, so if you start typing something, it will give you suggestions on what it thinks that you want to do, which is very useful for something like Unity, which has a vast amount of functions and all sorts of functionality that you can use.
So here I just put this print statement that says D key is pressed. So update runs 60 frames a second about. So every frame is checking if the D key is being pressed. And if it is, it'll run the code inside of here. Right now, it'll just print the D key is pressed.
Yeah, and it'll print that to the console.
Mm-hmm. So I'm going to save this and test it real quick. So let's go back to Unity. It'll take a second to compile the code. And after that's ready, there's this play button. So right now the game actually isn't running, but you hit play and it'll start running. It'll take a second to load. So you'll see this hello, it happened once because the start function only runs the code once. While right now, every frame, it's checking if the D key is pressed. And if I press it right now, it says the D key is pressed. And it's actually happened already 99 times just from that 1 second I had it pressed down. So that code, you can kind of start getting an understanding of like how much work a game engine is doing every second. Because there's no other way to really know if the D key is being pressed if you don't check constantly. So now we actually want, let's hit on play. Oh yeah, did everybody get that working, by the way? Everybody who's following along? Is there anybody who got stuck getting that?
Yeah.
Sorry, can you put up the code one more time?
Yeah, sure.
Yeah, if you're having any trouble following along, please speak up or type in chat, and we will be happy to assist you.
Is there any questions so far of like what this code is doing or just about the game engine in general?
Do you have to have that specific code editor?
No, you might
Okay.
have one that's like monodevelop or something. When you hit
Yeah, I
edit
have
code,
Atom.
Atom. Oh, okay. Yeah, any text editor should work. Capitals are.
Can you show how to? Oh, to play it, it's just the play button at the top
Yep.
of the Unity screen. Okay, just
So
thank you.
if you have what I have, it should start off with hello. And if you have something wrong in the code, you'll get an error and it won't let you play. So in a more advanced game like Call of Duty or whatever, you would have like tons of inputs. It would have like WASD, and each one of those would control the movement. So you'd have a bunch of these, but these would be different. And you could have like left click and stuff like that to like activate shooting and stuff like that. Key code R to reload.
Yeah. Another cool thing is that in our case, we're using Unity's built-in keyboard input manager, but that input actually doesn't have to, it doesn't have to be a keyboard. So that's where we start, sort of moving beyond into like physical tech and how it intertwines with Unity, is that you could use like, if you had say a button that's connected to like an Arduino or some sort of like little board or little microcontroller, that's when you start moving, past a game into, you know, something that's more physical, interactive. So just a little side note.
Yeah, so like if you wanted to, you can make like an escape room that, you know, that has like a virtual screen that like looks outside, and you could have like a physical button that you press which talks to Unity that makes the screen do something.
Mm-hmm. Cool.
Danielle, it looks like you're still having trouble. Do you want to talk through it a bit?
Yeah, I have an error message and I'm not sure what it means, so I'm going to see if I can look it up, but you guys can go ahead.
Okay. Yeah. So what we should do next is when the D key is pressed, we need to actually move the player. And to do that, we're going to have a new line that says transform dot position. So transform is actually specifically referencing this component right here. And then when we do dot position, it's specifically accessing this row, which has 3 axes, right? And you do dot x. So now we're specifically accessing this number, and we can like set it to whatever we want, like 1, 2, any number. But what we want to do here is actually add to the position. So if we want to add a specific, okay, let me write this out so I can explain it. So equals just sets the number, right? But plus equals, it actually adds to the existing number. And then, oh wait, okay.
Could we use like
so,
translate or something?
yeah, that's another thing you could do too. There's like 50 ways to move an object in Unity.
Yeah, we're just going to be demonstrating one simple way, but yes,
Yeah.
there are like 20 different ways that you could do this.
You could also, Unity has like a built-in physics engine, so you could use that and actually apply a force so that it interacts with physics really well. Okay, so I remembered, so you can't actually add to the X position, you have to actually add to the entire position.
Yeah.
Okay, let me. So right now what it's doing is that it's creating a vector, which is just an X, Y, Z.
Yeah, it's basically, it's an object that represents a direction.
Mm-hmm. So this specifically is just 0.1 in the X direction, and we're gonna be adding that direction to its current position.
Every frame.
Yeah, so right now, as you're holding D, it will increment this X position right here by 0.1. But the problem with that is that if your game is running at different frame rates, so if you have like a crappy computer that's like running 30 frames per second and a fast computer that's running 100 frames per second, they're actually going to move at different speeds. So we actually need to multiply this direction with a thing called time.delta time. I might have spelled that wrong.
I think T is capitalized.
T is capital. So this basically is the time it took to complete calculating one frame.
It's the change of time between frames.
Yeah. So if you're having a really fast frames per second, this will be a small number and it'll move a little bit. While if you have a really low frames per second, this will be a big number. So it basically balances it out so that no matter how many frames per second you're running, it'll always move at the same speed. Yeah. So if we save that, go back to Unity.
Yeah, and as always, this is being recorded, so and we will take questions at the end. So if you're having a little bit of trouble following along, you can go back and watch, or you can ask us anytime.
So I'm going to hit play. And if I hold D, it's moving incredibly slowly. So that's something we could actually change. So we could just do 0.5. So it should be 5 times faster. Make sure you save the script every time, by the way.
Should you use a serialized field for that or something? Or?
Yeah, so one thing you could actually do is create a variable. So you could create like a public float. Float is just, for this example, it's just a variable that stores a number. speed. So speed is the name of the variable, float is the type of variable, and public means that, I'm not going to get into that right now, but it'll, there's a lot of things we can't get into because we only have an hour, but it's going to make our variable show up actually in this component. So I'm actually going to use this variable here instead. So instead of going to the code and changing the speed every time, we're just going to be using this variable. And
So
this
if you save
variable
that and then
will
go
actually
back to
pop
the
up.
editor,
Ta-da! So now this speed variable popped up and you could actually input it from here instead of going into the code every time. So, you know, you could set the speed to be whatever you want. So let's try 0.5 and play. So now when we hold D, it moves. It's still pretty slow. You can actually change the speed while you're playing. There we go, that's a bit faster. But one thing to really remember about Unity is that if you change information in the components while you're playing and you hit unplay or pause, stop, it goes back to how it started. So you don't want to make important changes while you're in Unity or while you're playing. Now what we can do is we can make it so that you could collect something. So we're going to create a new object. Let's make a cylinder and move it to the right. And I want to squish it down so it looks like a coin. Rotate it this way. There you go. That's our coin. Now we're going to do a thing that detects collisions in the script, and that actually requires an extra component called rigid body, which is Unity's physics system. And yeah, I'm going to apply that to both the cylinder and the coin. So they both have the rigid body component. I'm going to set them both to is kinematic. That stops gravity from working because I just don't want to deal with gravity right now. And that should be good. Okay, so let's go back to the script. And now this is something we're actually going to do outside of start and update. We're going to do a thing, oh boy, oh, it showed up. So on collision enter, so this is IntelliSense, and it's like the autofill we were talking about. And so if you're in the middle of typing something and something pops up, you could hit tab and it autofill stuff like that.
yeah. So Unity has a lot of different special functions that handle, that only run in certain cases. And this is a good example of that.
Mm-hmm. So whenever there's a collision, everything inside of this script runs basically. And this other right here is a variable that refers to the collider with whatever you collided. So for this example, we could say something like print, you collected the coin. So whenever you bounce into the coin, it'll print this. And we actually want to destroy it. So it's like, looks like you collected it.
Wait, isn't it going to collide with the floor? Oh, wait, no, because you're not touching the floor and you don't have gravity.
That's a good point. Yeah, we'll see what happens. It
Forget
might
what
actually. But since we want the coin to disappear, we're just going to destroy it. Destroy. Did I spell that right? So like I said, other would refer to the whatever it collided, so it would be the coin in this case. So other, and we need to do .game object. Other refers to the collider component, but we want to
object is capital and game object.
Autocomplete has crippled me. Yeah, so this refers to the coin's collider, and we need to get that collider's game object.
Yeah. And by collider, he means the component that is attached to that game object.
Yeah.
So that's sort of demonstrating the object component relationship. You have an object, you have components that are attached to that object.
Yeah. So if I go back to the coin, you see this capsule collider. A reference to this component is actually going to be piped in through this function, and we could access that right here and destroy it. So when we hit play and I move to collect the coin, it should print something here, and
Are you
it
touching
should
the
disappear.
floor? Because it might destroy the floor. too. I don't know. Doesn't
Nope,
matter.
we're good.
Nope, you're good.
Oh, that didn't work. Ah, perspective. We're in a 3D world. Okay, so I'm gonna need to move that coin so it actually touches it. So when you hold D and it collides with the coin, nope. Interesting.
I think you should use on trigger instead of
Right, okay. So there's colliders can be like a kind of like a physical object that like is hard and collides with things, or you could click this if trigger, and that makes it kind of like a ghost. So physics will kind of ignore it and won't collide with it, but anything that enters that kind of
yeah.
space
Because
will trigger it.
we're not using gravity, the collision detection or that function doesn't
Yeah.
work as proproperly. So
And because it's a trigger now, we want to look for triggers, not collisions. So we would change this function name to on trigger enter, and hopefully that'll work.
it should work.
Wait, but wouldn't like both of them kind of have like the same like purpose in a sense? Like, because if you once you touch it like with like an on collision, it'll do the same thing technically with the trigger.
Technically, yes, but since we're using kinematic, it's very complicated physics stuff. But yes, you are right. They would technically do the same thing.
One cool thing about Unity is it has really cool or really good documentation. And I'm going to look at that to make sure I'm not doing something wrong.
So
What?
if I want to make an actual like wall, what would I use? Would I use the on trigger or would I use the collision?
If you have if you're using Unity's built-in physics system with gravity, then you would use on collision.
So I think this needed to be collider.
Collider instead of collision. Yeah.
Yeah. So Unity documentation has like a lot of documentation examples, and that helped me out right now.
Hey guys, whenever I hit play, my cylinder disappears. Do you know why that might be happening?
The coin?
Yeah.
This one disappears?
Yeah, it's like I hit play and then it just disappears.
And the player's not like overlapping it from the beginning like that?
Well, no, I don't think so. Because then I hit pause again and like it's still gone. It just like erases it.
Yeah, I think for mine like fell through. It
Oh,
just kept
okay.
falling and then it disappeared.
Yeah. Yeah, you'll want to hit is kinematic. Maybe it fell through the ground or something.
I think it fell before I could.
Okay, so maybe I need to turn off gravity. I think I missed how to do that.
Okay, yeah. So
Yeah,
if you
sorry,
go to
we
the
were going a
capsule,
little quick through
That's all good.
more to talk about.
under the rigid body component, there's is kinematic, and that might be the issue.
Okay.
Let me check to see if mine works. Yay, I collected the coin. And that's a game. We made a game, guys. Yeah, but that shows like the really basic examples of how game developers, or not even just game developers, but people who use game engines could, use input, make an environment, have things in the environment react to the player's input, which is like what a game engine is all about.
Mm-hmm. Cool. Any questions?
Yeah.
Before we move on to our next part.
I have like a more of like an advanced question for Unity. So me and a partner of mine, we're doing like a research project based on Unity, and we're having trouble like sort of like communicating with each other. Not as far as like texting or like emailing each other, but more as in like sending the Unity projects itself. What would you say is the best way to send our stuff through email?
I would personally, if you have experience with version control, I would use GitHub, or I would learn Git. Git is a very great tool for for version control and for storing code, because it tracks all of your changes so that if you mess something up, you can go back and fix it.
Yeah.
We're not going to explain it too much in depth, but if you have any questions about that, please feel free to message me afterwards.
Yeah, you might want to look at the GitHub desktop too. It's just a user-friendly UI. It essentially uploads a version of project to a cloud so that everybody stays updated and are working from the same project.
Yeah.
So like the professor that I'm like working on with this, he's kind of old and I don't think he can like learn GitHub. He just kind of wants us to create a game and combine it together. So like, is there a better way, cause so like email would be the best way for like this professor. So like, cause like right now what we're doing is that we're just like, anytime we need to send something to each other, we have to zip it up in a RAR so that way Google doesn't yell at us. And then we send it to each other that way. But like I just got his scene, like because he made like 2 new scenes. I just got his 2 new scenes, but he added a couple of prefabs and they're not, well, like not necessarily prefabs, but like he added like a couple of things that weren't added in the scenes that should have been there, but like they're just empty. And so we just want to know like what are some better ways to go bypass that, because I know that like if you like right click on assets and like specific things like that, you can just like export it that way. So I don't know if there's like some other hidden ways that like we could go about it where we could just send the entire game and it'll be fine.
Do you need to send the actual project, like the Unity project itself? Like all of the asset files, all of that stuff.
So, so I think that as far as like the assets, like I think we would need to send it, but like as far as like me and him are concerned about, like I mean, I guess me and him can get GitHub, so that way it'll work better. But like, yeah, I guess that'll be better just for me and him to work on. Then we'll just like zip it all up.
So, what it sounds like for sending it to them, you would want to create a build of the code. So what that would do is package up the entire project into a program that you would run like a game. And we won't, get into that too much, but that's something that I would look into.
Yeah, that's what I tried doing. But like I didn't like, because I tried to just send like the build itself, but wasn't like it kept saying that like Gmail just kept saying that it was a virus.
Oh, interesting. Yeah, well, that's another issue entirely.
Yeah. If you want to talk more about this, we can later. We're pretty open with communication.
Yeah, we'll definitely we'll help you out with that. But
okay, thank you.
Yeah, no problem. So yeah, let's move on to sort of our last sort of portion. So let's sort of tie this all back to themed entertainment. So give me a second. I will screen share our presentation again. Cool. Uh-oh. Is this working correctly?
That looks weird.
That's weird. Okay. All right. Slight technical difficulties. We are going to share from PowerPoint instead of the presentation window. Cool. Awesome. So game engines and themed entertainment and beyond. So we're going to, sort of show you 2 examples, 2 well-known examples of uses of game engines in entertainment. And, sort of now that you have this framework of, what a game engine is and how it works, we'll sort of break down, everything that's happening in these scenes. So how many of you guys are familiar with Millennium Falcon Smuggler's Run / have ridden it? Cool. Awesome.
Lucky.
Yeah. Yes, Kain still is not. Yeah, this is, pretty much the most well-known interactive attraction at the moment. So hopefully you guys don't mind spoilers if you haven't ridden it. But yeah, let's take a look. Uh-oh, is it not letting me go full screen? All right, give me 1 second. I'm just gonna bring this up on, sorry, slight technical difficulties. I'll bring this up on. Cool, have it right where I want it. Share screen. Can you guys see? Oh, whoops. I think I have to share my sound too. Give me 1 moment. Can everyone see?
Yeah.
Okay, awesome.
Yeah.
Cool. Can everyone hear all right?
Yep.
Right pilot, push the flashing button to take off. Pilot on the left, move your stick to fly right and left.
Okay, so for those of you that are familiar with this attraction, basically what we have here are different sort of roles that every guest plays. We have 2 pilots, we have 2 gunners, and 2 engineers. And what's happening is the guests are, pushing these buttons that are in this, the cockpit of the Millennium Falcon, and it's communicating with this game engine. So this entire attraction is run in real time using the Unreal game engine, which is pretty similar to Unity. And so, yeah, so let's sort of talk about what's happening here. So we have our gunner that's pushing buttons, and when the gunner pushes a button, what's happening is it's creating these objects, as like we saw in Unity. And these objects are set to travel in a certain direction. They have a look, they have a texture to them, they have lighting on them. These are all sort of components that are attached to that object. So every time we push that button, it's going to spawn a laser, and that laser is going to travel. It has a position that's moving, and then it hits the geometry and or the scenery, and the scenery is set up in a way where it has code that detects when that laser hits it, and when it does, it can tell when that happens, and then it will spawn some particles, or it will blow up the ship. It'll create an animation, play a sound, etc., etc. God, I love this approach. Yeah, so basically there's this constant communication between what the guest is doing, between the buttons and the game engine, and then from the game engine back to the ride vehicle, because there's a lot of lights and physical effects that are happening in the capsule, in the pod. So this constant feedback loop is what it's what makes this attraction so unique, and why game engines are amazing. Cool. Awesome. So there's a really great example of sort of the use of game engines. Next, we'll sort of talk about, let's see, how many of you guys have seen The Mandalorian? Okay. Well, I don't believe this video has any spoilers, but Let's sort of take a look at this video, which talks about how game engines were used in the production of The Mandalorian.
Part of what's been fun about collaborating on The Mandalorian with Lucasfilm and Disney is that we have been able to see through a few technical innovations and a few firsts that I think are going to have a lot of impact on the way television and movies are made moving forward. In partnership with ILM and Epic, we have put together a system whereby which we can have game engine, real-time render, and video wall technology coming together to create a backdrop for the big, beautiful world of Star Wars.
The volume is 21 feet tall, it's 75 feet in diameter, run by 7 machines, pumping the visuals onto the screen that's being created in pre-production and can be on the screen within 24 hours of being finalized.
It's incredibly impressive when you first walk out there because it completely surrounds your peripheral vision. And you really quickly forget that you're indoors and you're not out on some planet's surface. It feels like a real three-dimensional environment surrounding you because it is a three-dimensional environment.
You can allow your key creatives to all make decisions together so that the shots are captured entirely in camera, which allows for a better performance.
And what was so exciting about this is by bringing those people together, things started to click, and we started to realize, well, let's not just do green screen and interactive light. If we're going to design the whole set and game engine ahead of time, maybe we could have some in-camera effects.
Everything in the volume is designed to both light the actors and to be a background that we can directly photograph. So you end up with real-time final pixels in camera.
If you look at visual effects heavy films, you've got a film set and then it's going to go to post and it's going to get the world put in. Here we're considering all of that at the same time, and how do we create a background and foreground that live together on the volume harmoniously.
When we started to play with the idea of using Unreal Engine for virtual production, that's one of the things that Richard and John started to embrace, is that you've got this very dynamic world where you can have randomization of things and find the happy accident that gives you the perfect shot. Being able to see the actors point at things and see what they're looking at was pretty transformative. It gave everybody context, with the added benefit that if you want to move a mountain from there to there, you can do it instantly.
You could switch between the Iceland location to the desert location, all within the same day of shooting.
The ability to shoot a 10-hour dawn is extraordinary. To shoot any sequence where you say, oh, this world's not quite right, let's just move it a little bit. An extraordinary number of benefits and advantages for shooting in that environment. It's mind-blowing what that tool is.
What you see is really what you get. And that's something that really means a lot to filmmakers, especially those who have worked with a more traditional approach in the past.
Shots of character in a vehicle traveling through a complex environment is always very difficult to do believably on stage. LED screens are a wonderful solution to that problem, because what you're doing is you're taking this technique of image-based lighting that we've been using in computer graphics for years, and use it to light a subject.
And then we would do shoots where we would texture map real lit surfaces onto our game engine Geo, and so the camera could move anywhere. We would do interiors, like Werner Herzog's office. And then you started doing things like building sets into it, having half a spaceship with reflective surfaces. And so it became exciting because by the end of the season, it was like, let's start designing sets around what this could do well.
Just like the good old days.
With Star Wars, we're building on a rich legacy of innovation, and getting to partner with Jon Favreau to make his ambitious vision a reality, it's really a game changer for filmmaking.
Cool. All right. Man, that video gave me goosebumps. right. Well, we are just about done. If anyone has any, lingering questions, we'll stick around. But yeah, other than that, Kain, do you have anything else to add?
Yeah, so like VR is like another use of game engines, which I think is really cool. It's really good for previs. So if you want to like design like a theme park ride that's like totally interactive before spending millions of dollars to build it, game engines would help you with that too. Any other questions?
If there are no other questions, I just want to say thank you guys so much for presenting. I learned a lot from it. I thought it was really great.
Yeah, of course.
Oh, the resources. Do we have that?
Oh, right. Resources. I don't have a slide for this, but
okay.
yeah, some good resources. Definitely the Unity tutorials. Unity has a world-class series of very informative tutorials. That will basically walk you how, through making your first game, et cetera, et cetera. And so you can get a feel for, all of the other features that we, didn't have time to talk about. How do you choose between Unity and Unreal? That's a great question. Unreal is generally used for a lot more, I guess, visually spectacle stuff. It also has a much higher learning curve than Unity. So generally, we like to recommend starting out with Unity and then learning Unreal. But yeah, it definitely just depends on the project, different needs. Unity is actually getting a lot better at, sort of rendering very high quality stuff, comparable to, sort of the stuff that Unreal can do. But yeah, what kind of files can you import into Unity? Also a great question. So Unity supports all sorts of things. Like if you're talking 3D models, Unity supports pretty much every major, file format out there. You can export from Blender, Maya, AutoCAD, pretty much anything in terms of that. For sound, WAV, MP3, you got all your sound files.
I think you could actually import like Photoshop files too.
Can you really? See, I
Don't
didn't
quote
even
me,
know that.
but I think I could before.
Cool, yeah, but if you can, if Unity supports it, and you can think of it, then it probably supports it. So.
Yeah, we only had an hour and we've like barely scratched the surface of like the power of game engines. I wouldn't even say we scratched it, we like touched the surface maybe. But yeah, if you want to learn more, there's also lots of cool YouTube tutorials from channels like Brackeys. Yeah, and they're all free, so that's great if you want to learn
we'll
more.
Type these in chat if you'd like to save them.
And like I said, the Google, you could Google stuff in Unity really easily because so many people use it. So
right.
If you have a problem, it's probably already been like answered in some other form.
Yeah, that's one of the benefits of using such a common, well-supported engine is that, pretty much if you are trying to do something, odds are someone else has tried to do that before you. And they have tried and failed before you, and they hopefully figured out how to do it. So, Google is your friend. Yeah, Brackeys, Unity tutorials. Also, the Unity API website. Kain briefly, sort of demonstrated it earlier, but that's also a great way to sort of delve into all of the different functionality that you can use via code. So, and there's also a lot of great usage examples on those API pages. that are very helpful.
Oh yeah, if you want to like contact us, because some people had like, or that one guy, I don't know if he's still here. He had a lot of
I'm
questions.
still here.
Justin.
Yeah.
I still need help with that thing because
Are
I
you
could
on the themed entertainment students Discord?
Yes, I am.
Yeah, I'm
Awesome.
on there.
Yeah, you
My
can reach
username
both
was,
of us on there.
I was typing
Yeah.
our username so they could actually find us. So I'm Kain on the Discord.
Yeah.
Do you mind if after this, like, I go on Discord and I just show you like the whole like thing with the importing? Because I have like my Unity like research thing up, and it's just that I'm just really having trouble like because like right now like it seems like as though like there's no lighting, but there is lighting because I don't know like what's getting like imported and what's not actually getting imported, and it's just really difficult to like have this communication problem.
Yeah, I don't know if we could do like a video call, but if you like send us like screenshots of like the problems that you're having, and like I think we could get to you.
Sure.
Yeah, we can help you out.
I'll send the screenshot, and I'll just post it on Discord right here. So like, what I'm gonna just send right now is the so I'm sending you the level that he made, like one of the levels he made, from like the prefabs I have. So it's not like as though he added any like new prefabs. But yeah, I just wanted to say this towards the end because it is like advanced and very specific. So.
I just changed my nickname to Kain Shepard, by the way, so you don't need to search for a username.
Any other questions?
Yeah, I also have just another specific question, but it's also it's about the colliding because I just can't get it to work, but we can talk about that after.
Okay.
Sure.
Well, in that case, I will go ahead and stop the recording, and then you guys can chat about the coin thing. So
I'll go on the Discord voice chat because I also might want to share my screen to show you guys like what I'm going.
Absolutely.
Yeah. Oh, and as far as like the coin thing, because you said it was falling, make sure you turn off gravity so that way it doesn't fall.
Yeah, I got that far. It's just I think I clicked all the things to make it collide, but it's not. It just goes right through. So I just wanted to make sure I'm doing everything correctly.
Okay.